We're going to go ahead and get this started. I think we can make this happen. Welcome, everyone, to our second meetup. This is a big honor for me to be interviewing you, Zach. If anybody cannot see it, you've got Zach's bio here. He's the Senior Director of Platform Operations at Optoro. And we spoke a few weeks back about this whole data on Kubernetes community. And we thought, wow, let's try and talk about something, because you are what I would say quite opinionated around this subject, and you have an ability to convey your ideas in a very simple and easy to follow manner. So I am very happy to have you here with us. I want to thank you first and foremost for coming and chatting with us today. Our conversation is going to be around storage, doing storage right. We're also going to open it up to everyone. That's something that I want to just make clear. This can be participative. Is that a word? There, so we can all get into this, because I know we're not the only ones that are doing data on Kubernetes here. And if you have at any point some kind of ideas that you think this could be done better, or why are you doing it like that, feel free to ask us questions. That is what we are here for. We'd like to have it be a community, not just two talking heads up here. We can have more people join in. So as we get started, I'll unmute everyone in case you want to talk with your microphone. If you're feeling a little shy, you can always just drop it into the chat, but feel free to get involved. Now, Zach, I'm going to start with how I normally start. I'm just going to ask you how you got into tech.
So in a real long way, I guess, I couldn't get Wing Commander to play on my 486, and so I had to learn how to free up enough high memory, for anyone who remembers MS-DOS, to play Wing Commander. From there, it was just kind of like, oh, you can like edit these things and you can change things, and when I got a Sound Blaster, we had to figure out like IRQ channels, and so that progressed to like BBSs. I'm not sure if anyone remembers BBSs, but I was in there. And then from there, it just kind of became like it was something I could do on the side, and wasn't something kind of made sense to me. And then eventually, people were like, "Well, how would we get like a website up?" And it's like, well, I don't know, you just kind of like you just read the docs and then you kind of do it. And so over the years, it just became like, well, I think my first professional job where I had to maintain servers, I was technically the administrative assistant. I was opening the mail at the front, and then someone's like, "Yeah, we have these like Dell servers. We can't get them to like run anything on them." I'm like, "Well, I can fix that," And so from there on, it's just been, 20 years of fixing crap.
Yep, never fails. So can you talk to us a little bit about Optoro? And I know it is labeled as reverse supply chain logistics. And so can you just tell us what the hell that means?
Yeah, so that's a funny term, right? So the way I kind of try to explain it to people is, um, retailers are really good about getting things into customers' hands, right? You buy 1,000 new iPhones, they come from China, you have them hit what's called a forward logistics position warehouse, and then those get sent out to either directly to customers or retail fronts or get listed. And in some ways it's easy. I have 1,000, they're all brand new. You want an iPhone 11. So the problem is a couple fold, right? Our classic scenario is really like, what happens when you buy that iPhone 11, you've got it, you're super happy, you've bought all the accessories, and then you go back, and the next day the iPhone 12 comes out. Well, clearly the iPhone 11 is trash at that point, right? You don't want that thing. And so as a consumer, you go back to the retailer and you're like, hey, let's go ahead and just make that exchange. They sell you all those accessories again. They're happy to do it. You're a happy customer. They've sold 2 things. Now they have an iPhone 11. It's perfectly good, but they don't know what to do with it. So what ends up happening is they take that, and this is kind of what happened before. They take that, throw it in the corner and fill up. They'd send it back to like a local warehouse. Local warehouse's corner would fill up, or the equivalent of it. They'd send it back to a regional. Eventually, that regional warehouse would look around and be like, "We've got all this space being sucked up by excess inventory and returns. We don't even know what we've got in there." So they would call us like Lou's a liquidator, right? And liquidators come in and they kind of just look at it and go, I don't know, you got some iPhone 11s in there, you got some other stuff, but the iPhone 11, that's old, And so then they kind of buy all that. They would then start palletizing it. They'd throw a lot of it away. They would then sell off big chunks of it to like sort of the filings basements, the sort of the discount shops of the world. Some of it get listed on eBay, everything. The problem is, just as long as that explanation is, that cycle takes a long time and takes a lot of touches. And so what ends up happening is every time it's getting touched, it costs money. There's a carbon footprint incurred with shipping. And eventually, someone might have really wanted that iPhone 11 a month around you returning it. But 9 months, a year later, iPhone 12s have discounts now. No one's really buying the iPhone 11. So the value of it's dropped off for the retailer and the desire for the consumer. And honestly, the older it gets, the more likely it's just going to get thrown away. So what we do is we work with those retailers to get embedded as close as we can into their workflows, into their reverse logistic workflows, so we can capture that excess and returns goods coming in and get them to the right homes immediately. So we have our own channels like Blink and Bulk.com, and then we list on Amazon, eBay, or our own customers' sites. And so what we're doing there, and this is sort of our classic, we call e-commerce sort of side of our business. But what we're really trying to do there is, one, just reduce that number of touches. And that's how we deliver value to our customers. They get just more money back from those things. And the second is we get to reduce a lot of carbon from the atmosphere because we're just not shipping junk around everywhere. Instead, it's like it gets returned. We can receive it at a warehouse, scan it. It gets immediately listed on these marketplaces. And literally by the time it gets to the end of the conveyor belt, it could be sold.
Oh, that's awesome.
And so that's kind of what we do. And we use a bunch of tech to power that, make good decisions and stuff on that.
Yeah. And we use a bunch of tech to power that, we'll get into in a minute. But can you talk to us a little bit about like, who are some clients that you're working with?
Yeah. So obviously, like, this isn't a solution that, sort of the corner store buys, right? You're trying to send something to them, they probably put it back on the shelf. Our customers are the Targets and Best Buys and IKEAs of the world. We build enterprise software. We're an enterprise SaaS, and we build and sell enterprise software.
Awesome.
So you kind of like large retailers are our sweet spot, Under Armours and things like that.
Yeah, that makes sense. That makes total sense. So now let's talk about the tech, and let's go into, I know I told you before we started that I was watching your, the video you did with GitLab last year, back when we could meet in person. And, and so you were talking about just how crazy your whole system was, right? And, but before you talk about any of that, I'd love to know just, what does your stack look like these days, and how are you running things?
Yeah, so nowadays, and so we're an outlier in a couple ways, I think. One is we're pretty much 100% on Kubernetes, which, having talked to some other folks, that a lot of people I found are doing initiatives, but they still have these other footprints, and that's not true for us. We're basically 100% Kubernetes at this point. And the other outlier is we're in a data center. We have servers and racks with blinky lights, and we have direct connections to the internet, and we own our own IP range and things like that. So those are two kind of qualifiers I'll throw out there, because we are a little funky that way. And I'll tell you that the reason we do that is because we are a very steady state operation. We run a lot of state, and realistically, we don't have sort of services that scale, that need auto scaling and kind of take advantage of the elasticities of the cloud. And so in about 2015, we actually moved out of the cloud and into our own data center for cost reasons. And so, tech-wise, we're on-prem. We pretty generic, right? Like just Ubuntu 18.04 LTS. running on the nodes. Maybe a little weird as we run ZFS for all of our storage. And again, part of that is we've made obligations to our customers that will encrypt everything at rest, and ZFS can do that for us. Also, I'm cheap and I don't want to buy RAID cards. So I don't have to buy RAID cards if I run ZFS. We also get checksums, consistent storage that's super performant and allows me to do some neat things with it. So probably the most like interesting thing on these boxes is that they're just ZFS on Linux is probably the most exotic thing there. But otherwise, it's just bog standard. Where Intel boxes right now are going to probably try some AMDs later.
Yeah, and that was one of my questions I wanted to ask you about was cost and how that factors into everything. But maybe before we get to that, because I think that could be addressed in a minute, let's just talk a bit more about like storage, because that's
Yeah.
kind of what we said we were going to touch on, right? Can you go into what you're doing around that?
Yeah. So when we started into this whole like let's move to Kubernetes proposition, this was sort of one of the things, like how are we going to do storage? And this is I want to say a year and a half ago. So some of this experience is dated for sure because Kubernetes moves forward really quickly, as we all know. But we kind of just started going down these paths, and basically everything we found for on-prem at that point was either like big alpha warning tag on it, or it was a vendor trying to be like, hey, we'll sell you some fancy box to put into your data center. But the truth was, like, and this is before this we were running on a platform called Joint Smart Data Center, which also they called Triton. And in Triton, we never had distributed storage. We only ever had local storage. And so we never really had this real addiction to ever increasing volume sizes. And we had become very used to the performance characteristics of local disk. So when we moved into Kubernetes, we're kind of looking around and saying the same thing, like, well, do we want a complex distributed system to run on top of our complex distributed system to provide storage? And kind of the answer came back to, we do not have a data set that is larger than a box, that isn't in a system that is already clusterable. And if we were to look at the failure characteristics of those systems, and these are like Postgres, Kafka, Elasticsearch, MySQL, Redis, things like that, none of those lack a replication or clustering story. And we still have to know how to run all of those, right? We don't get there's no get out of jail free card because we're going to have distributed storage, right? This would solve some problems for us for sure, but it would be like we'd be taking on a lot of extra responsibility by doing that. And so what we looked and said, well, like k8s, right? Like keep it simple, stupid. And so we just moved forward with the idea that we should be able to use local storage. There's disks on a box. All we're asking is for a Docker container to spin up. And that storage can be local to machine. And frankly, the application is going to probably do a better job keeping replication and quorum than shifting all those blocks at the lowest level possible.
And can you talk us through how that looked when you were examining everything? Like, how did those meetings go, and who ultimately how did that choice get made?
Yeah. So, and this is, it's always funny when you look at these decisions in hindsight. Like, we definitely have some, like, we didn't want to lose the performance characteristics of local storage. And so everything we tested, we're like, okay, like as long as we're close, we'd probably be good. So we spun up sort of the usual suspects at the time. Like I'd run Ceph at a previous organization. So we spun up Ceph, we spun up Longhorn, and Longhorn was like alpha then. So like they've come a long way. And we were kind of like, okay, so definitely, like we set these up. We did a little bit of tuning as best as we could figure out, and then we started just doing our basic MySQL testing was our sort of our benchmark. That's sort of like our largest database is this kind of older MySQL thing, and it's also the database that scares everybody because they're all like, if this thing can't perform, like we might be in trouble. So we started doing disk performance testing, and it was just distributed storage was just orders of magnitude slower. And so we're kind of stepping back and being like, well, can we move to a system that would be slower than the system we're on? That's a hard sell to an organization, right? And so, good or bad, we had addicted the company to a certain level of performance and storage. And as we're kind of talking about this, let's a very large project to move to a new platform. We can't. You got to limit the number of asterisks you're putting in there, right?
Oh yeah.
Because certainly, if you put one there and it's like, oh yeah, and storage is going to be distributed, asterisk, and and they're like, well, what's this? Wait a minute, 10 times slower. What the hell are you doing, right? So we kind of ended up in this position of like, well, wait a minute, we've got storage. MySQL can do replication even if it's crap. We run Kafka. Kafka knows how to distribute partitions and take advantage of local storage. Same thing for Elasticsearch. We didn't want to take on that extra level of complexity without honestly, while we were trying to drink from the fire hose of learning and deploying all of our stuff onto Kubernetes. So really we went some kind of like did some performance analysis. We did some market analysis, kind of went around, saw what was out there, what we could find, what was we're built pretty large proponents of free and open source software. So kind of leaning towards that more than anything. And then we went, we kind of did that. We went through the performance characteristics, trying to run our own load tests for the workloads that made sense for us. And then we kind of looked around and we're just like, I don't know how we can do this. And if we want to do it.
So Waleed was asking, and I think you kind of answered this, but he's saying local storage with some replication. Just
Yeah. Well, so what we do, and the thing we're able to do, like I said, with ZFS, ZFS will let you create Z pools, and that's just think of as a RAID. So our bog standard SKU right now has two 3.8 terabyte disks, SSDs, and then we confront those with two 1 terabyte NVMEs, and so both of those get put into a mirror. And then what happens with ZFS is you can do what's called a ZFS intent log. Just pause real quick. Anybody who has acronyms with an acronym inside of it can die in a fire. Keep going there. So the ZFS intent log sits on the NVMEs. And so what that means is because ZFS is a copy on write system, when we flush to disk, we're getting the performance characteristics of writing to NVMEs. But then they flush behind the scenes to the slower SSDs. So you're able to read from either SSD because it's a mirror, right? So you have that double channel effect of being able to read from either SSD. So we get good, solid SSD, read performance. But we're able to leverage the NVMEs for write performance. So instead of having to acquiesce those writes all the way to the SSDs, we're able to front them with the NVMEs and get a really solid write performance characteristics on these boxes, while we're able to build out those pools as needed behind the scenes if we needed more capacity there. So we're locally replicated in terms of we have a Z pool on the machines, but then we're counting on the applications doing the right things for replication on top of that.
And just a bit of a tangent on the ZFS train that we're running.
Yeah.
Last time we spoke, you were mentioning how ZFS has its pros and cons. Can you talk a little bit about those cons?
Yeah. I mean, for sure. Like it's not. It's newer to the Linux world than a lot of the other file systems. It's definitely geared towards consistency, which means translate it can be slower. However, you get to get rid of a lot of complexity out of your life. You don't have RAID controllers anymore, or you don't need them. You can have encryption done locally at the disk. We get a lot of value out of the compression. So we actually save a fair chunk of money just because on general we get about 1.5 to 2x compression on all of our pools. So if I have an 8 terabyte data set, realistically I'm only writing 4 terabytes that to disk. So I just buy less disk. But it is something you kind of have to be aware of. It's a bit of a piggy sometimes. So it is designed to run on servers, right? And it assumes that it can take large chunks of memory to work for what they call ARC, which is the adaptive cache. And so it really has a lot of assumptions of I'm running inside of a server environment. And some of the implementations, because it is newer inside of the Linux world, they're not quite as solid as I'd like to see them. I'll give you an example. One of the things that's been biting us lately is the way kubelet makes decisions on disk pressure and placement and a bunch of other stuff. Is it runs this command called in ZFS you can do ZFS and then make commands, right? So ZFS get all, and it then takes all of the metadata that can be returned from these the data sets, and that's cool, except that what we also found is Docker doesn't do a great job of cleaning up after itself. And so we have some machines that have 30,000 data sets. And then when you do the -t, because the way Docker makes ZFS images is to take snapshots of every image it pulls down, then combine them, we really have 60,000. So in a local lab, if you're running this and you'll see kubelet spinning out a ZFS get all, whatever, it takes a second or two to return, no big deal. It's like 15, 20 data sets it's iterating over. We've seen this thing run for like an hour before. And that can be blocking on other ZFS operations. So we'd see these like periodic timeouts. And we're like, what the hell are you doing? And so as we've dug into it more and more, we're like, why would you ever call ZFS get all in a loop? And it's because it's the dictum there is very much around the idea of like, oh, well, we'll just call this in a Go routine, and we'll just kind of constantly we'll wait on that channel and then we'll return the results. And I get it, but there's notifiers inside of ZFS they could be doing instead if they were trying to look for straight statistics on data sets, or if they were trying to look for deltas or events happening. So like you hit these weird scenarios where they're like, well, of course you should be able to do this, and it's like, no, like that's not going to work. But just complete side tangent. The other side that's real fun about the encrypted thing, the encryption works great. We don't see any problems for performance or anything like that. But when you boot up, you have to decrypt all of your file systems, and that's done serially. So normally not a big deal, except if Docker's managed to vomit 60,000 file systems onto your ZFS out of that. Because then all of a sudden you're like waiting and you're like, what the hell is this? Oh my God, we're still importing data sets. It's like, oh, come on, Docker.
Oh, that's so perfect. So moving on, and thanks for that little tangent on ZFS. I love
no worries.
hearing that kind of stuff. But I'm wondering, there's going into more of the organization of how you're doing stuff. Do you have two separate teams on, like, is there the platform team and then the engineering team that is doing stuff, or is it just you taking lead on all of that? How does that look?
No, so I'm a pointy haired boss, right? Like I make decisions, I sit in meetings, I delegate to people, I do all of that sort of fun stuff. I have a team that works underneath of me in infrastructure, that's what I call them. We also get referred to as DevOps, but sort of weird because as the director of DevOps, I feel like I'm like the czar, like a czar of communist intent or something like that. It's like, here's, you have a cultural movement, and I'm going to have someone who's like the cultural enforcer of it. So I was never super comfortable with that. So we call them infrastructure. So with the infrastructure team, who the idea is they build pipes, they don't turn wrenches. So they build the clusters, they build patterns for those things. You can think about like the implementation of the operators, the clusters are backing around the cluster security, things of that nature. And they get all the way to the point of, now here's CD and here's the pattern to follow to deploy your stuff. And we have a chunk that we call, and so we use a tool called Argo Cd. And so in there we have generally two projects. We have the infrastructure project, which is all of the things we need to run our world. And then we have what we call business apps. And so the business apps are all the things that the feature developers are building and pushing. So in our world, the feature developers are responsible for delivering a Helm chart that will CD into the world for them. Now, we've made a bunch of examples. We work with them to deliver that. we're going to help them understand, like, do you need an ingress or don't you need an ingress? How, these are your choices for operators. So we have winnowed down the available options of sort of blessed things that can go into production. But generally speaking, like, we're not sitting around and deploying this stuff for them. They're actually doing all of this. The developers are generally pushing into building and deploying all this on their own.
Nice. So let's talk a bit more about storage and
Hmm.
what you're doing with these stateful stores on Kubernetes, and why you told me it's a challenge, but there's also
Yeah.
it's got a lot of value. Can you talk about what the challenges are and what the values are, how those pros and cons weigh out?
Yeah. And so, the explanation I usually, or the angle I have come around to on this, I guess is the way I would put it, is Kubernetes is a great scheduler. And I think that's what all kind of gets us down this road, is it's a really effective scheduler. It exposes a lot of knobs. There's a lot of great things being done there. What the challenge is that, and there's two locations. One is networking in my mind, but also storage, where there's a bit of a hand wave where it's like, yeah, we do some stuff there, but probably cloud provider or something. Yeah, yeah. And my issue here is that I believe, or want to believe, that Kubernetes is this, like, generalized universal API that we're going to be using for building and provisioning things. That gets complicated if then we're saying, but you probably have some very specific implementation details around possibly two of the most important things in your stack. So the benefits we get by running these stateful stores inside of our stack are pretty good, right? Like, how do you build and deploy things? Kubernetes. How do you get the operators out there? Kubernetes. How do you find what resources? They're just resources in Kubernetes. Just use a service identification, isn't it? There's no magic. There's not multiple patterns. We understand it and see it one way. We can talk about our storage and the stateful systems the same way we talk about everything else. So having that one way to think and look at the world is hugely important. And the storage aspect of it, like, the data is what makes it possible. But if we were running it all to USB drives, or whatever behind the scenes, I don't think anyone would care, right? Like, the fact is, we can deliver those stateful services on demand inside of the same resources that our developers are using to provision the rest of their stack. They can think about it in the same terms that they can think about their applications. So that's hugely important. There's some downsides, right?
And then, yeah.
Yeah, right. So then there's downsides, right? And some of the downsides are things like, it turns out etcd is crap. Just, I mean, it's crap, right? Like, so we've definitely hit problems where it's like, oh, well, like, we should be able to span clusters across multiple data centers, because certainly this thing that's powering all of these clusters and as a key value store has an understanding of being able to implement a WAN protocol for you get any latency, you're screwed. And now the problem with that is, and to be fair, these are things that are the Kubernetes folks are doing, are making progress on, is that we have trapped a lot of this knowledge inside of each individual cluster. So now you're looking at it and saying, cool, I've got my state, but it's probably trapped in one spot, or the knowledge about that state is trapped in one spot. So the same thing that made this really excellent, in terms of I can understand the world and I can talk about it in the same way and I can ask the same API for all of this information, and I have one concern in the world, also limits us to, crap, I might be stuck in one spot. And now again, we hit this very interesting inflection, right? If everything I know about the world is stuck in one spot, I can either architect around that by saying, well, I'm going to do something clever inside of this spot so that this other cluster knows about it. Or we say, okay, these applications, we're just going to go in and hand jam them somehow so that we have IP transit between two spots hey, you can have a MySQL replica over here. It'll just be hard coded to know about something over here. There's a lot of progress happening with like HCO and others, where they're kind of saying, you guys suck at this. We're going to take over cluster federation. Um, but now you have Istio. And Istio has its own challenges and complications. And are you going to have everything doing MTLS? Are you going to allow for outside actors? Are you going to be able to do things on, I hope you don't need host ports for anything. Istio doesn't like host ports. So we've kind of got this, like, again, we've got all of our state, we can reference it the same way, but are we now in a position where we've maybe done some damage to ourselves? And I think that the funny part about this is no, because most of the applications know what the fuck they're doing. And mostly what they'll do is they'll say, well, like, so we use Crunchy for our Postgres, and it's pretty good, right? It does a good job. And one of the things you can do is stream your wall segments off to S3. And like I said before, we're not in the cloud, but that's just because that didn't make sense for us. We still take advantage of cloud services. And so in this case, GCS, S3, all those are things we still use. If the bill gets too big, we'll run Minio. But the interesting thing there is we can take those wall segments and we can stream them somewhere else. And if we can stream those wall segments somewhere else, it means we can just consume them from somewhere else. So these are kind of solved problems in a lot of ways. You can do Kafka Mirror Maker if you want, although there's some hair on that dog with like the way cluster, again, you have to have IP transit. They kind of have to know at each other. The Kafka operator we use wants to know about both sides of things. It's a little tricky. But we're still in this world where individual Kubernetes clusters and state is something you can do. We do it. Coordinating state across multiple clusters is something that is a whole nother academic exercise. Because again, like a lot of the primitives you really want to have happen, even if you're talking about the storage layer, they're just not there on the Kubernetes layer yet.
Yeah, that's exactly echoing the point that Patrick made last week when he was talking about, the primitives weren't built with data in mind. And I remember talking to you about like an ideal situation when you're working with like storage classes, and I think you echoed what Patrick was saying on that too, like, can we just make storage classes for data storage on Kubernetes? Can we make that simple and easy? And you also were talking about another thing that I can't exactly remember. I don't know if you're going to be able to remember it either because it was before your vacation, but it was something like that. Like, in an ideal world, how would you see this working?
Yeah, I mean, so I think there's a couple things, right? Like one, we need those cluster primitives, right? We need to be able to ask questions more easily about the state of our cluster or other clusters. And to be fair, like HashiCorp does a much better job at this than Kubernetes. Like hands down, we were a HashiCorp shop before, and like they did a great job of that. You could just simply ask a remote peer about it, and it would find out the answer for you. So this isn't like magic we have to figure out. One of the things I've been, kicking around the idea on is I do believe that a lot of the applications we work with and we try to shoehorn onto these platforms actually already do a lot of the things we want them to do. And we need to make it easier for that to happen. And honestly, a lot of that is really about getting those primitives exposed inside of Kubernetes. And sort of the canonical example I give for this is if I have persistent local storage for a machine, and I'm doing that because it's Kafka or Elasticsearch or something like that, where I know I need throughput, but I also know I have this thing replicated like 5 ways anyway. So do I replicate that again 5 ways inside some sort of erasure coded distributed storage system? Or do I just say, no, it's cool. If a node blows up, just reschedule it. The cluster knows what to do. Right now, because we have these PVC claims or PV claims, what will happen if we lose a node is nothing. Kafka won't get rescheduled because Kubernetes examines the state of the world and says there's a PVC. That PVC can only be can only be fulfilled by this node who has taken the claim out. So if we have a node pop and say it's a Kafka cluster, we have to go in and delete the PVC. And then Kubernetes goes, oh, I can schedule you somewhere else. Cool. I'll go schedule you somewhere else now. Now the machine makes a PVC, gets scheduled, Kafka sees it, world gets happy again. But if we had a primitive there that said, hey, just like my deployments, I always need, if I have 5 of these, I always need 4 healthy. But if one dies, you can just go ahead and delete its data and reschedule it. It's cool. The cluster knows what it's doing. But we haven't done that. We haven't started to treat storage with the same emphasis that we have in terms of like being able to give hints to Kubernetes about the world that we have done with sort of what we like to think of as stateless apps. And so what I see this hopefully going towards is we'll be able to start giving those scheduling hints to Kubernetes and being like, yeah, in this group of PVCs, I always need 4 to 5. But if one dies, go ahead and just reschedule it. And here's how long, and here's how you tell the health of the deployment to be able to know if you can lose another one. Because we wouldn't want the scenario where it schedules one, the cluster is still yellow, something else happens and it kills it and goes, oh cool, like I'll go ahead and take care of that one too. And then maybe you're in a bad spot. So there's obviously like failure scenarios all over that, which is again why state is hard, but also probably why we want to do it. Because I guarantee you I don't know a business that can say that is stateless, right? There's no business I know where they're just like, no, we don't keep any state about anything.
Yeah, of course, it's an important piece of the puzzle. And we were mentioning before everybody jumped on, or while everyone was jumping on, kind of the elephant in the room. And you had told me that Kelsey Hightower was mentioning, or he tweeted, I can't remember what exactly it was, but he was saying,
no. Let's just I'll throw it right up. I've got it up right here. Yeah, let's call it out. Can everyone see my screen okay? Yep. Kubernetes has made huge improvements in the ability to run stateful workloads, including databases and message queues, but I still prefer not to run them on Kubernetes. Thus spoketh Saint Hightower. I mean, this guy is like the patron saint of Kubernetes, and I'm not trying to say he is wrong. And at first, when someone sent this to me, I was like, man, maybe I've done fucked up good. Maybe we've made some like real bad decisions, and I just need to start looking.
And you haven't realized it yet.
Yeah, but then I kind of got thinking about some more, and it's like it was sort of this bit right here. This like has made huge improvements in the ability to. If we had listened to Kelsey Hightower's advice from the beginning, we would have never made improvements to run stateful sets. Because his advice before this, and there's another tweet I just didn't bother digging up, was don't run stateful sets, or stateful services, I'm sorry. Don't run stateful services on Kubernetes. Well, if we'd all kind of listened to that and hadn't kind of noodled through our specific problem sets and figured out, no, there's some things I just like that's taken care of better for me by this operator, and that operator can use local storage and like or whatever, distributed storage or whatever. I'm just going to move on. That highlighted portion would have never happened. So I'm not going to say Kelsey Hightower is wrong, because the dude knows a lot more than me about Kubernetes, just hands down. But I do think like these are we're only going to get the world that we actually try to build. And Kelsey Hightower is probably not that interested in solving this particular problem. I think it's important to solve, because I do see the cognitive load of running these systems has always been high. And when we were building these systems out, we decided we did not want to run like a VMware or a VM solution on the side for databases and Kubernetes, and then have the complexities of marrying those together and have 2 systems to manage and have 2 ways to talk about the world. having one single declarative way to think about our world has really enabled us to focus and drill down into solving problems a lot more effectively than I think if we had to split our attention into two places.
Yeah.
And even when we sometimes have done fucked up and are in this spot where um, our stateful sets on Kubernetes are giving us grief, stateful workloads, we still learn about those things. And we learn not only about the stateful workload, but we learn more about Kubernetes.
Hmm.
And because we learn more about Kubernetes, we've strengthened that cycle of being better at the thing we want to be better at versus, oh no, I got really good about running MySQL on Proxmox and load balancing with HA proxy. Like you can do that, but you have to be good at that now and all the inconsistencies and how you'd orchestrate that and inject that back into maybe use console and, and do some sort of bridge back into Kubernetes and you get some native exposure there. But is that where we want to spend our time? So this is what I was talking about with the elephant in the room. I think Kelsey Hightower has got a great point. It's not perfect yet in any way, and I'm not going to be the guy that tells you that. We had a maintenance window the other day, and our MySQL database went sideways because the operator decided to do something stupid. But at the same time, we had one way to look at that world, and because all the engineers on the team are all living in that world, they could all start looking at this Kubernetes space and saying, "Hey, this is what I'm seeing in these logs. I'm going to go look at this pod. Hey, let me check the stats for this for the workload." And they could all start diving in and using all the same tools they already knew and understand and work with every day. Versus, okay, well, let me go into log into GCS or Google Cloud and look for the RDS there, and let's see what's going on with it.
Yeah, and that's like one of the reasons why we're here, right? To talk about this stuff and to try and evolve it and to learn more about it so that we can see where we can improve it and hopefully make it better. And so that one day maybe Kelsey's tweet is going to say, "All right, finally, I switched over. It's good now." He gives it the stamp of approval and we're all happy. But I think, yeah, we could look at it like doing it now, it's somebody's got to blaze the path or
Yeah.
trailblaze in a way. And I really like your viewpoint on it, saying, well, it's one way to look at the world and you don't have to go and have two different parallel universes that you play in. So uh, along those lines, can we talk a bit about operators and what operators you're using? I know you
Sure.
put in the
Yeah.
Slack earlier that you're using Crunchy, right? And then
Mhm.
what other stuff are you getting into as far as in the operator land, and how does it work, and how do you see it? What do you think about it?
Yeah. So we're using Crunchy for Postgres. Um, I used to work at a company that had a lot of DBAs and where they had DBA consultants, and the Crunchy guys are clearly DBAs. I wish that they would write a better operator. And we do spend some time modifying their operator to do things slightly more native to Kubernetes versus how maybe the DBAs of the world would think. But it does a good job, and they've actually added in, I think it was like the 4.3 release, the idea of offsite clusters. So you can have your on-site, so you have, say, cluster A, and you have a primary and a replica, and then you have backrest streaming out, backups, and I can't remember what they use for it's not wall G, it's something else, for streaming the logs, the wall segments to S3. You can then instantiate a standby replica in another cluster that will just consume the wall segments from S3. So this idea that you can kind of get DR out of the box across air-gapped Kubernetes clusters. So those clusters don't need to know anything about each other. So that's pretty cool. Now, that one we lean on a lot, and it's probably because so the world I live in we're mostly a Ruby on Rails shop, and so Ruby on Rails makes it really easy to use databases, and so everybody uses databases. So we have something in the order of 40 production databases, which is
Wow.
not my favorite thing in the world. We also use for MySQL, the operator pickings were a little slimmer at the time, and so we use one works pretty well called Press Labs. So the Press Labs operator manages MySQL databases. We haven't, we've kind of only have one scenario where we're using that. And then for Kafka, we're using Strimzy. And I like Strimzy a lot. That one's worked really well for us. In general, I think Kafka is a, if you're going to run a message bus because that's what you want to do, Kafka's pretty stupid if you use it right. And that's worked well for us. And again, like we're using local storage for all of those. And then we use the ECK operator from Elastic for our Elasticsearch cluster. And that one is probably the best of the Elasticsearch operators. Elastic has its own issues in general, but that's principally for our we principally use that for our logging stack, and the issues we've run into that are more just Elastic has made decisions over the years and they haven't implemented everything the ways we'd like them to do it sometimes. And so there's a lot of like cursing at Elastic sometimes with their stuff. But yeah, I'm trying to think what other operators we use. We're using the OpenEBS CRD for local PV on ZFS. So they'll do all of the ZVol creation for us underneath the covers, and that works well. We finally just made our decision on secrets, which we're going to be moving towards using actually declarative. We're going to be using Mozilla's SOPs. So I don't know if anyone's worked with that, but Mozilla has a secret sort of like keyring management you can do, and then you embed the hash into your charts. So we're actually specifically trying to get out of the way of like using something more complicated. Again, just trying to keep it as simple as possible there. I think what other operators we use.
If anything else comes to mind,
yeah,
you can throw it out later as it comes up. But I see Tyeth had a question here in the chat asking about, have you set up an OpenStack setup or staying self-managed?
So we do not have an OpenStack setup. I have done OpenStack in the past. That would have been about 6 years ago. That's probably last time I touched OpenStack. But yeah, right now we're all self-managed Kubernetes. We use Rancher for our distribution and sort of the management plane of that. But yeah, otherwise we're just, again, 100% Kubernetes, trying to keep it really focused.
Yeah, which is an awesome ethos to go by. And so
yeah, but you do get the shortcomings, right? Like,
yeah,
you definitely do.
Yeah, until it gets better, right? And or you make it better.
Right.
So you were mentioning you got like 40, what was it, 40 databases that you have there? Is it all, did you go all in on one provider, or is it like a mix, a variety? What's that look like?
No, it's almost all Postgres at this point. Mostly Postgres 11 and 12. I think we've finally got rid of all the last of the 9s and the 10s. And that's all being managed through the Crunchy operator. And it's funny because like we hit a lot of issues with their 4.1 or whatever release it was, because the way they would manage the databases was they would essentially examine every namespace they had access to, and then they would look through all of the databases and they would see if anything needs to be done. The problem was we've had so many, the operator was running too slow. And so when we'd go to do things, the operator was too busy just trying to watch all of our databases, so it couldn't even provision a new one. So we figured out like how to kick it just right so that like a new database would like come into, like would be conceived into our environment. But yeah, they changed that a bit, but that was not fun. And it's one of those things that you also get to a point where you're like, crap, like like can I even run our stack anywhere when we've made certain decisions? Because like not all of these decisions are on our hands. I think any organization, there's always give and take. We're always looking around and saying, hey, I've got Engineers over here, this is what they know. These are the tools they have. I need to be able to provide them X, Y, and Z. The goal really is, again, like I was mentioning before, is really build pipes and get out of the way. So with the operator patterns, that's great because we say, hey, here's the blessed sanction ways. We've kind of pre-stubbed everything out. So like, if you follow these patterns, import this chart, you'll get all the good standard defaults. You won't have to worry about backups. Those will happen automatically. You'll have metrics and that'll happen automatically. Your DR scenario will be covered for you automatically. You know, it's like check, 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 check. The bad part about that is if you're going to say you're not going to be a gatekeeper, you can't really be a gatekeeper later. So we did it. We have ended up with 40 something databases, and with clean hands, that our engineers can just say, but you said we could.
Yeah, you can't really say much when you set it up like that, can you?
Right, right.
And so now I'm conscious that we're running out of time, and I want to ask you two more questions, but I also want
Sure.
to make some space in case anyone has any questions they would like to ask Zach. Feel free to throw it into the chat or unmute yourself. You should all have talking privileges. I want to hear some war stories. You gave us one earlier, but I want to hear like what was a time when things just didn't go right, and why did that happen? How can we prevent ourselves from doing the same?
I mean, I've screwed up a lot. So let's limit it to Kubernetes because that's probably more interesting to folks. I'm trying to think of a good one. So a constant pain point we've got is still around this like idea of like building pipes and getting out of the way. And for for me, this one is always annoying because we have a bunch of Ruby on Rails apps, right? And people love it because they can get stuff out quickly, and there's this, you know, they feel there's a great developer experience or something. I fundamentally disagree with most things Ruby on Rails does from an operational perspective. And one of the ones we hit all the time is logging. And so a place we spend a huge amount of time is actually tweaking and kicking our logging infrastructure, mostly because we were at the point where we're generating terabytes of logs. And again, this is on compressed storage, and text compressed pretty well. And the thing is,
Wow.
the Rails infrastructure really likes to tell you everything it's doing. And it really likes to let you know that it did something. And because it's a framework, it's just like, I don't know, you might want this or not. And then where we end up with a problem is that, and kind of going back to this idea of like, maybe we done screwed up making it too easy. Our developers can just go in and change how many pods they want and things like that. So because Ruby on Rails doesn't really do threads, Ruby doesn't really do threads, so it's single process. The way that we essentially have been able to scale and manage resources for Ruby is by using containers. And so we enforce CPU restrictions and memory restrictions by using a container. The downside of that is that developers are very clever. And when they need to scale, they realize they can just go in and change that to 100 containers. So now you have 100 of these things crapping out logs into our infrastructure, and it's super entertaining. So that's one thing where we've definitely had some issues. I'm trying to think of a really good one with around Kubernetes that, like, yeah, because then we get this cascading effect where like our Kafkas start to fill up because we have a retention period of, like, we use the default retention period because they have hundreds of gigs of disk. So what's the big deal? And then we found like they were running out of disk because we had 2 weeks of retention. So we had to trim that to a week. And then our Elasticsearch clusters start filling up. And then we're going in there and just being like, well, what the hell? And so we use this Kafka library, and it basically would have a heartbeat, and it had hard coded the heartbeat at info. And it would just basically say every second, like, processing a message, processing heartbeat. process. So every one of these containers across this entire fleet was just like sending in thousands of messages that just basically all said the same thing. And we're all just like, yeah, process this processed heartbeat message. And it was just like, what? What the hell are you doing? So we actually had to put a filter in. So we do FileBeat, Kafka, Logstash to Elasticsearch. So Logstash in the middle has a regex pattern looking for processing heartbeat and just drops it on the floor. And so that was an amusing one. I think one of the others we found around ZFS and Linux is systemd. I don't know if there's any systemd lovers out there, but I've got feels. I can do a whole rant on that.
Shout out to systemd lovers.
Yeah, they for whatever reason need certain POSIX ACLs enabled on their files so that journal D will work correctly. And so we were trying to debug an issue, and the entire dbus or dmessage was full of all these systemd journal log error messages about ACLs. And we're just looking at like, the hell do you need special file permissions for logs? I don't know why I'm ranting about logs so much today. Maybe it's just a theme lately. But yeah, so like we had to go in and enable a bunch of like ZFS POSIX ACL conventions to enable journal D to work correctly and not spam D message.
Incredible.
Yeah.
I love it. I love hearing about this. And as our last note to finish up, we've got about a minute. I want to know what you would like to see for the future of doing data on Kubernetes. Is there anything that you feel is particularly important?
Yeah, I mean, I think we need. So again, like I think if we think about, there's two things. One, I think the state needs to be scheduled better. We need to be able to give hints. We need to be able to do those things. We need to be able to provide a little bit more than just give me 100 gigs. And I think that the sort of the other side of that, we really need to, in my mind, again, like I really see Kubernetes as this is going to be the way we provision things across multiple providers. This is where we can take cloud providers and really say, yeah, I know you have your own implementation, but I'm going to treat you like a utility. And the advantage there is like, if you need to go into a new environment, it's not like, well, we need to go into China. Well, we're an Azure shop and they don't have, I'm sure they have data centers there, but like, so, but our client wants us to be on Alibaba. Okay, well, everybody retool all your Terraform. We've got to get to Alibaba. It'll just be like, well, we can run Kubernetes there, and we'll have this implementation, this API that we're all gonna. This is our contract, right? Like this is what's gonna hold us together. That being said, that means we need to get better about keeping all of these bits true. So that like, if we're gonna say there's a snapshot API, right now we say that for like importing, or for taking for executing a snapshot. And then it's kind of like, well, that snapshot should be compatible with the storage that you've chosen, et cetera, et cetera, et cetera. Why? Why can't I say, no, Kubernetes, we said this is what a snapshot looks like. We've taken a snapshot. I should be able to restore that to any CIS compatible, CSI compatible snapshot enabled storage. Because now I can say, hey, we need to import the data set into China. Okay, well, take a snapshot and push it over. Does it matter if the storage providers are different? The hell cares? I want to be able to write to the API. I want to be able to work against that. So as we move down this path more and more and more, we have to remember that like, we don't want to get stuck in a world where it's vendor soup and there are these implementation APIs underneath the covers and you can do some things, but then you have to remember in these other places, those don't work. And that some of these vendors support it a little different. We need to be consistent all the way through, and that goes up and down. So anything we're putting down the stack through those agreed to standards has to be able to come back out the stack. And I think we do a good job going down the stack, like the snapshot API, et cetera, but we don't do it the other way yet. And that's going to be really impactful for data moving forward.
That's a brilliant vision. I love hearing how you see it. I love talking to you, Zach. I really appreciate this. It's been super insightful for me. I've learned
Awesome.
a ton. I hope everyone out there listening has also learned a little. I really appreciate what you've done and taking the time to teach us a bit about what you all are doing at Optoro. And thank you from all of us at Data on Kubernetes. You are in the Slack. So if anyone is not in the Slack, I'm going to go ahead and put that again in here. We have a Slack. If anyone wants to follow up with you, the best way to talk to you would probably be on that Slack,
Yeah.
or
Yep. Yep.
you're also on Twitter and
Yep.
LinkedIn, those places. So big thanks, Zach. We'll see you all next week, same time, same place, for more of this fun talking about data on Kubernetes. Really appreciate it. Have a great day, Zach.
Hey, thanks for having me.
See you,
A lot of
everybody.
fun.